Hello everyone. So today we are going to discuss Codeforces Round 959 Part C, Hungry Games. So in this question there is a guy named Yaroslav and he is playing a computer game. And at one of the levels he encountered N mushrooms and these mushrooms are arranged in a row. Each mushroom has its own toxicity level. The ith mushroom from the beginning has toxicity level of AI. So the toxicity level of ith mushroom is AI. Now, Yaroslav can choose two integers, L and R. These integers will be between 1 and n. The value of L and R can be equal. Okay. And then his character will take turns from left to right and eat mushrooms from this subsegment of the array. And the mushroom is eaten one by one. Okay, so basically if it's selected L and R, then the mushrooms will be eaten like this. So it will eat the Lth mushroom, then L plus 1th, then L plus 2th, up until the Rth mushroom. So that's how the mushroom will be eaten. Now the character has a toxicity level G, which is initially 0. So initially the toxicity level of the character is 0. The computer game is defined by the number X. Okay, so the computer game is defined by a number X, which is the maximum toxicity level at any given time. So X represents the maximum toxicity level. And when eating a mushroom with a toxicity level K, the following happens. So if he eats a mushroom with a toxicity level of K, then the toxicity level of the character increases by K. So for example, his toxicity was G, right? Which was initially 0. But at some point, the toxicity might be G, which can be anything, can be 0, cannot be 0. Then after eating a mushroom whose toxicity level is K, then his toxicity level will become G plus K. Okay, so that's how it goes. Now in case G is less than or equal to X, what was X? X was the maximum toxicity level of the game. If G is less than or equal to X, nothing happens and the process continues. Otherwise, G becomes 0. So after doing this operation, if G becomes greater than X, then you reset G back to 0. That's what the question is saying, and the process continues. Now, Yaroslav became interested in how many ways there are to choose the values of L and R such that the final value of G is not 0. It means the final mushroom that he eats should not lie in this condition, that if toxicity level K is added to it, then the value of G becomes greater than X and finally it has to be reset to 0. This should not be happening when he eats the final mushroom. Okay, so you have to help Yaroslav to find the number. So this is our input format. So obviously the first line contains the number of test cases and the second line contains two integers n and x. N represents the size of the array which contains the toxicity level of each mushroom, and x represents the maximum allowable toxicity. And the second line of each test case contains obviously the toxicity levels of the mushroom from A1 to AN. It is guaranteed that the sum of n over all the test cases does not exceed 2 times 10 power 5. It means that n times t will always be less than or equal to 2 times 10 power 5. Now, for each test case, output a single integer, the number of subsegments, such that the final value of g is not 0. So let's analyze a test case. So let's take this example test case. So the maximum allowable toxicity level is 2. It means the value of x is 2 and the toxicity level of the mushrooms is the same. All are equal to 1. So it's 1, 1, 1 and 1. And yeah, the answer for the first test case is given below. These are the subsegments which are possible. So how many subsegments are there? 1, 2, 3, 4, 5, 6, 7, 8. And that's why the answer is 8. So let's see. So it says 1 comma 1 is a subsegment. It means we are taking in only this element 1 comma 1. So if we take in only this mushroom, what's our toxicity? Obviously the toxicity will be 1. Is 1 less than 2? Yes, it is less than 2. And yeah, we are not ending at a toxicity level which is equals to 0. So that's why 1 comma 1 can be taken. If we see 1 comma 2, if we take 1 comma 2, then we are taking this subsegment, right? What is the toxicity level if we start eating mushrooms from here to here? So it will be 2, right? It will be 2. Now 2 is still not greater than 2, right? So this is a valid subsegment. Now, if we take 1 comma 3, let's say we take 1 comma 3, okay, then we are taking in this subsegment, right? So if you're taking in this subsegment, what is the value of our toxicity? The value of our toxicity will be equals to 3. 1 plus 1 plus 1. So the value of toxicity will be 3. So our toxicity of our character will be equals to 3, which is greater than x, right? Which is greater than x. So what happens in this case? In this case, remember, the value of g becomes equals to 0. So instead of value being equals to 3, the toxicity resets to 0. Okay. So if we are taking the subsegment 1 comma 3, we are ending at g equals to 0. But we only have to select those subsegments in which the value of g is not 0, and therefore 1 comma 3 is not a valid subsegment. However, 1 comma 4 is a valid subsegment, because when you start eating mushrooms from here and when you come here, the value of g becomes equals to 0 over here, right? Now, if you take in one more mushroom, what is the value of g now? The value of g will become equals to 1, because 0 plus this mushroom. The value of g becomes equals to 1, which is again less than or equals to x. So we can take in 1 comma 4. That's why 1 comma 4 is a valid subsegment, but 1 comma 3 is not. So basically the value of the toxicity of mushroom gets added up one by one, and whenever it becomes equal to the value of x, then the toxicity level of the character resets to 0, and we can start adding the toxicity level again, just like we did over here. Here the toxicity was 0 because 3 was greater than 2. Again it becomes equals to 1. So that's why 1 comma 4 is a valid subsegment, and similarly all of these are valid subsegments. Now let's think, how should we come to its solution? So let's build our approach using this example test case. Remember, the question asks us to calculate how many subsegments are there. We have to calculate the number of subsegments that are possible. So what we are gonna do is we're gonna iterate over our array, and we will check, like if we set this as our left element, if we set this as our L, then how many possible values of R will be there? Like starting from this element, how many subsegments can we have? This is gonna be our approach, and after finally finding out the number of subsegments starting from each of these values, we will add them all up, and that is going to be our answer. So why not start from the last element? Because calculating the number of possible subsegments starting from the last element is quite easy, because there is no other element after this element, right? So starting from this last element, how many subsegments can we have? So this is the value of our L. How many values of R can we have? Obviously our R has to be here if we are going to include this as our left element, because there are no other elements after that. But the question is, can our L and R be here? Can this be a valid subsegment? Assuming a zero based indexing, so it's 0 1 2 3 4 5, can 5 comma 5 be a valid subsegment? The answer is no, because if we are gonna eat this mushroom, the value of g is gonna be 8, right? The toxicity of our character will become equals to 8, which is greater than 3. So it will reset to 0. So if we consume this subsegment, we are ending with the toxicity of 0, which is not our target. Our final value should not be 0. We have to find those subsegments in which our final value is not equals to 0. So that's why this is not a good way to end. So how many subsegments can we have starting from this? So starting from the fifth index, how many subsegments can we have? The answer is 0. I'm gonna store it somewhere. Let's store it in an array. Let's call it dp. You see where it's going. So I'm gonna say dp of 5 is equals to 0. So starting from the fifth index, there is going to be no subsegment. Let's not talk about starting from the fourth index. Can there be a subsegment or not? Okay, so if we start over here, can we include 4 comma 4? The answer is yes. If we include 4 comma 4, 3 is not exceeding 3, right? So one subsegment is possible. Now can we include 4 comma 5? No. If we include 4 comma 5, the value of g will be 3 plus 8, which is 11, which is greater than 3. Yeah, so it will reset to 0 again, which is not our target. We don't have to have the final value of g as 0. So starting from the fourth index, we can have a maximum of one subsegment, which is 4 comma 4 only. So we will store it somewhere. So say dp of 4 is equals to 1. Now let's talk about starting from the third index. Now starting from the third index, can we have 3 comma 3 as our answer? The answer is no. We cannot have 3 comma 3 as our answer, right? But can we have 3 comma 4 as our answer? If we consume this, then the value of g will be 4, which is greater than x. So it will reset to 0, right? I'm going to say this again. Suppose our character consumes this. The value of g is still 0, right? Because 4 is greater than x. If 4 is greater than x, then the value of g resets to 0. So even after consuming this, the value of g is 0, right? We are starting from here with value of g 0. It's the same as we are starting here with the value of g as 0, isn't it? If we are consuming this, it's the same as starting over here with the value of g as 0, isn't it? So can't we say that the dp of 3 is nothing but equals to dp of 4? Now let's come to this index. So when we set this as our left index, index 2, so how many subsegments can we consume? Can we have 2 comma 2 as our answer? The answer is yes, because 1 is less than 3. The value of g is gonna be equals to 1. And can we have 2 comma 3 as our subsegment? The answer is no. We cannot have 2 comma 3 as our subsegment because we are gonna be ending up with a value more than 3. So our g will reset back to 0 because 1 plus 4 is 5. Now let's think of 2 comma 4. Can we have 2 comma 4? If we have consumed 2 and 3, yeah, the value of g is going to be 5, then it resets to 0. So the value of g is 0 and we are at this index. So isn't it the same as dp of 4? Because the value of g was 0 and we were starting from here, right? So 2 comma 4 is correct, or we can say the value of dp of this index is equals to, so how many elements did we consume? We consumed only one element, which is 2 comma 2, yeah, and after that the answer is going to be plus dp of 4. So the answer is going to be 2 because the value of dp of 4 was 1. I'm going to explain it again over here. So let's write down all the subsegments first of all. So 2 comma 4 is a possible subsegment. 2 comma 5 is again not possible, if you see, because if you start from here 1 plus 4, the value of g will become 0 after this. Then you will include this, the value of g is 3, and if you include this, the value of g will become 11, which is again more than 3. So that there's only 2 subsegments possible. So here what we did was, when we are at this index, we first of all calculated like up until when is our sum less than or equal to the value of x. So up until only the second index, up until only 2 comma 2 is our sum less than or equal to x, right? And after that we are seeing that our sum is exceeding at this index, right? The sum exceeds at the jth index, right? So our answer is going to be j minus I, the number of elements. So basically it's only one element, so it's if j is here, I is here, so there is only one subsegment, which is j minus I, which is from I to I, and we are adding the value of this, which is dp of j plus 1. Let's come to another element. So let's come to this, the first index. So dp of 1 is equal to, so first of all, how many subsegments can we make starting from here? So we can make this, we can make this, but can we make this? The answer is no, we cannot make this as our subsegment. So there are two subsegments basically. So when we start our I, we will start I over here and we will start j over here, and we will calculate the sum. So the sum is 2, which is less than 3. Again the sum is 3, which is again less than or equal to 3. And if our j come here, the sum is 7, which is greater than 3. So the value of g will reset to 0, and we will have our g equals to 0 over here at this index, which is the same as p of 4. which is the same as dp of 4. So how many subsegments did we have in the beginning? So our sum is exceeding the value of 3 when the jth index is here. So how many subsegment can we have? Two subsegments. So we can have two subsegments, which is j minus I. We can have 1 comma 1, or we can have 1 comma 2, right? So we have two subsegments, which is nothing but j minus I, which is 3 minus 1. Yeah. So this seems to be the correct dp that we have written. So dp of I is going to be, we can have two subsegments plus the dp of 4, which is 3. We can have three subsegments starting from the first index. Now let's erase this a bit. Let's start from the first element, which is dp of 0. Okay. So can we have 0 comma 0? Yes, 0 comma 0 is valid. Can we have 0 comma 1? Yes, 0 comma 1 is also valid. The sum is 3. Can we have 0 comma 2? We cannot have 0 comma 2, right? We cannot have 0 comma 2 because the sum is becoming equals to 4, right? So the index at which the sum is exceeding the value of x is j. Okay, and this is our left index, right? So how many subsegments that we were able to make? So we were able to make two subsegments, right? Which is j minus I, right? After that, we will start with here. We'll add dp of j plus 1, because here the value of g becomes equals to 0. So isn't it the same as dp of 3? Isn't it? So I'm gonna say dp of 0 is j minus I, which is again 2, plus dp of, so it's 0 1 2 3 plus dp of 3, right? And what is the value of dp of 3? 1. So it's gonna be 3. So what is our final answer? So our final answer is 1 plus 1 2 plus 2 4, 4 plus 3 7, 7 plus 3 10. So our final answer is gonna be 10. So there are a total of 10 subsegments that we can make, and if we see our answer, it's also 10 over here. So that's how we should approach. Now let's see the brute force. Let's start coding our approach. So first of all, we are going to declare the size of the array and maximum allowable toxicity, and we will take in the input. After that, we are going to declare the vector of the toxicity level of the mushrooms, and we are going to take in the input of the vector. Now after this, we are going to define our dp of size n, and we are initializing our dp with zeros. We are going to start from the end of the array, right? So if the end of the array, if it's less than or even equal to x, then we can take in that element. So the number of subsegments that we can form with the end element as our left element is gonna be 1, isn't it? So we're gonna say the number of subsegments that we can form is gonna be 1 if it's less than or equals to x. However, we are gonna loop in our array starting from the end till our first element. Okay, and now we're going to define another index j, which will tell us up until when we can take our sum, and when is the sum is going to be 0. So where the j is going to be ending at is the point where the sum is going to be greater than x. So we're going to define the sum, and we'll start taking in the sum. So while j is less than n, we're going to add the elements to the sum. And in case if sum becomes greater than x, we'll stop here only. We'll break the loop. Okay, so we'll check after the loop ends. We'll check if sum is really bigger than x. If sum is really bigger than x, then we have already discussed that dp of I is equals to j minus I plus dp of j plus 1, isn't it? Otherwise, dp of I is simply the number of subsegments that can be formed, which is dp of, which is j minus I. Okay. Now, here it's an important thing to notice. The j plus 1 can exceed our bounds. So we'll just set a case. We'll just set a condition over here. If j plus 1 is only less than n, we're going to do this. Otherwise it's gonna be simply this. Okay, now we are going to set our result starting with 0, and our answer is going to be the sum of all the elements of dp. So we'll start looping on the elements of the dp, and we are going to add it to our result, and finally we are going to print our result. Now let's run our code. So all the example test cases are passing. Now let's try and submit it. You see, it's giving us time limit exceeded. You know why it's the case? It is because our solution is an O of n squared solution, and the value of n can go up until 10 power 5. So this is not the optimal approach. So now let's try and make our approach optimal. So this approach gave us a time limit exceeded. This is because we were running two loops. This first loop was running for a n time, and this loop was also running for n time. So our overall time complexity was becoming O of n squared. And since the value of n was around 10 powered 5, O of n squared is not a suitable solution. So our solution must be of O of n, or it could be O of n log n, but it should not hit O of n squared. Now let's see how we can get to optimize this. So what we are doing is we are basically calculating sum between I to j or L to R, and we are increasing the count of the possible subsegments, right? So how can we calculate this sum in a big O of one time without looping? Can we do this in big O of one time? So yeah, we can do this if you ever heard of prefix sum. In prefix sum, this can be done in O of one time. So for example, if we need to calculate the sum between the index I and j, the sum can be simply given as prefix of j minus prefix sum of I minus 1. So that's how we can calculate the sum between two indexes I and j, isn't it? Now we are targeting a sum which is greater than x, isn't it? We are targeting a sum which is greater than x. We are basically trying to find out the value of j where the sum is becoming greater than x, isn't it? So if sum is greater than x, this means this is greater than x, isn't it? Or we can say that ref of j is going to be greater than x plus ref of I minus 1. So we basically have to find this. So in order to find this, what we can do is we can take an upper bound in the prefix sum. So we can do an upper bound of this. Upper bound of this. Isn't it? Yeah. And from this upper bound, we can calculate the value of the j. So that's how our approach is going to be. And what's the time complexity in calculating the upper bound? It's gonna be log n because it works on binary search. So this question is a combination of DP and binary search. Now let's see and implement it in our code. Let's discuss the changes that we are going to do in our code. So first of all, we are also going to define a prefix sum, isn't it? So let's call it pref only. Okay, and size of it is going to be same as the size of the array. So the first element of the prefix sum is nothing but the first element of the array, and the rest of the elements can be updated like this. Now after calculating our prefix sum, we come over here. Okay, so we basically have to find out the value of j when the sum becomes greater than x. Okay, the index j when sum becomes greater than x, that's what we have to do. So we need to find an upper bound, as we discussed. We need to find an upper bound of what? We need to find an upper bound of ref of I minus 1 plus x, right? So we have to find it from the beginning till the end. Okay, and let's store it in some iterator. Let's store it in IT. Okay, so the value of j can be found out. We're just gonna say j is equals to it minus ref dot begin. So this will give us the value of the index, which is when the sum is greater than x, isn't it? So we don't need to do this process over again. We don't need to do any of this. We just need to check if j plus 1 is less than n, then we're going to do this, else we're going to do just this. That's it. And finally we are going to add up all the values that are stored in the DP, and we're going to just output the result. Now let's see if it runs. Now we need to be careful over here because pref of I minus 1 can exceed our bound. So instead we are going to define a previous, okay, which we are going to initialize it with 0. And if I minus 1, if it's greater than or equals to 0, only then we're going to say that the previous is equals to pref of I minus 1. And here I'm gonna write previous. So now let's run it. So it's passing the test cases. Let's run it and submit it. So let's paste it over here. Regains, submit it. So yes, it got accepted. So that's what our code is going to be. It's easy, it's simple, so we're just adding a binary search over here. That's the only modification that we needed apart from our brute force. I hope it helps.